Hi everybody, it's Linnea Tucker. This is Module 2, Lesson 2, Section 10.2, Rational Exponents. Today we're going to talk about understanding the meaning of 1 over a to the n, a raised to the 1 over nth power, a raised to the m over n power, and a raised to the m over, I think that's supposed to be negative m over n power. Don't like the way those are typed. They're hard to read. We're going to use rules of exponents to simplify expressions that contain rational exponents, and we're going to use rational exponents to simplify radical expressions. All right, let's do this. Okay. If you need a copy of lecture notes and you're on my roster, go to Moodle. I've got my PowerPoints there. For students not on my roster, go to this Google site. I have put PDF copies of my PowerPoint lectures out there. They're out there for every single lecture. You're welcome to look at them. Take handwritten notes. Okay. Do you remember your exponent rules? If you don't, it would be to your advantage to jot these down or go to Google and find an exponent rules chart and print that off. Because we learned these in CPM3, we're going to apply them now in CPM4. So it's definitely good to go back and review them. You can pause the video anytime if you want to, back it up. Okay, let's start with 3. And we're going to square it. And our result is 9. Inverse operation, if you can do an operation to a number, then you can undo that operation to that number. If we start with 9, we can use the square root and get back to 3. So squaring and square root are inverse operations. Okay? If I take the square root of 9, the result is 3. With a square root, the implied index is 2. We talked about that in lecture yesterday. If you don't see a number here, we assume it's a square root. Okay? And a square root means what number times itself equals 9, your radicand. Well, we know that's 3. Changing the number 9 to exponent form, if I take the square root of 9 and put it in exponent form, that is the, okay, stick with me, it's the square root of 3 squared. You can see the squaring and the inverse operation here. And that equals 3. Another way to write this is the square root of 9 is 9 raised to the 1/2 power. That is another way to write it. And when you change your square root to taking your radicand and raising it to the 1/2 power, this is called a rational exponent. Rational meaning the ratio of 2 numbers. Do you see the radical's index in the rational exponent? Here's the index in the radical. Do you see the index in the rational exponent? Yeah, it's the denominator. And what you can do is grab your TI-30, enter a 9, then your power button is the one that looks like that. I call it a caret. I don't know what it really is. But why don't you take 9 and raise it to the 0.5 power, since 1/2 is the same as 0.5, and hit enter. And see if you don't get 3. When you run this through your calculator, the answer should be 3. When you plug that into your calculator, your answer should also be 3. Grab your calculator and give it a try. Okay, so here's the definition of a raised to the 1/nth power. If n's a positive integer greater than 1, then the nth root of a is and the nth root of a is a real number, then a raised to the 1 over n is the same as the nth root of a. Okay? This one we're going to have to remember. Put a big star by it. It comes early in the lecture, and then we'll talk about it, and then you'll do a homework, and we forget about this until the test comes up, and then people forget about this. So let's not forget about this. It will be on the test. All right, let's use radical notation to write 49 raised to the 1/2 power, simplify if possible. Okay, 49 to the 1/2 power, what is the index on our radical sign? Yeah, it's the denominator of that fraction, that rational exponent. So that means the same thing as taking the square root of 9. Taking the square root of, 49. Taking the square root of 49, they're asking you what number times itself gives you 49? Yeah, that's 7. Okay, what about this one? What is this asking for? I've got a rational exponent, rational meaning it's fraction form. What are they asking for? Yeah, if we change that to radical form, what's my index? Yeah, my index is 3. And now it's asking me what number multiplied by itself 3 times gives you 8. Well, that's 2 times 2 times 2. 2 times 2 times 2 is 8. So I just wrote my radicand in prime factorization form. And remember from yesterday's lecture, this says if you can put groups of 3 together, 3 identicals, it will come out as a single. If you just run this through your calculator, and there is a button, I think it's above, is it above this one? And it says x to the that. Give that one a try. I think what you do to put this in your calculator is you're going to type in 3, then you're going to hit second because it's not on the button, it's above the button. Then hit that little symbol, put in an 8, and hit enter. You should get 2 as your answer. Give it a try. Pause the video, give it a try. You really need to know how your calculator works here. What does this mean? What does this mean? The negative out front, see that 1/2 exponent? That 1/3. That 1/3 exponent applies only to the base of the 8, but not the negative sign. If the 1/3 applied to the negative sign, it would be in parentheses. Okay? So since it's not in parentheses, let me see if I write it the way I want to write it. No. This is the same as taking -1 times 8 raised to the 1/3 power. That exponent of 1/3 only applies to the base of 8. Do you see how I left the negative sign out front? Okay, so our answer here is going to be what? Yeah, negative, the 3rd root. 8 is the same as 2 times 2 times 2. The index says group 3 identicals together, and it comes out as a single. But don't forget, they're wanting the negative root. Okay? There you go. Use radical notation to write the following, simplify if possible. 81 raised to the 1/4 power is what in radical form with a radical sign? What's our index? The index is always the denominator of your fraction, of your exponent. So they're wanting the 4th root of 81. Now let me take 81 and do this. 81, prime factorization. Well, I know 81 is 9 times 9, and 9 is 3, and this 9 is 3 times 3. This is our prime factors. So they're asking for the fourth root of 3 times 3 times 3 times 3. The index says if you can put 4 identicals together, it comes out as a single. I do it this expanded form, prime factorization form. When I used to teach it this way, people didn't understand that taking the fourth root of something raised to the fourth power are inverse operations. I had better luck teaching this module doing it this way. Takes a little bit longer, but people who understand the long way got better scores. Okay. Use radical notation to write 2m raised to the 1/3 power, simplify if possible. My question to you is, that exponent of 1/3 applies to what? The 2m? Just the 2 or just the m? Just the m. If it had applied to the 2 and the m together, those would be in parentheses. But since they're not, that rational exponent only applies to the base of m. So now let's rewrite this. That's going to be 2 times what? We're going to change this to radical form. What's my index? Yeah, my index is 3. So it's 2 times the third root of m, or the cube root of n. 2 times the cube root of m. See, we're starting to get a little more abstract now, aren't we? We're throwing in some variables. Okay. Square root of 36 is 6. Everybody agrees with that. 6 times 6 gives you 36. 36, 36. You know, if you start breaking it down, you could call it 4 times 9. If I do this prime factorization, I could say, well, 36 is 4 times 9. And I could keep going and say that's 2 times 2. And that's 3 times 3. I'm going to show you 2 ways to do this. I could go the long route and say, well, that's the same thing as taking the square root of 2 times 2 times 3 times 3. Now watch this. This says put groups of 2 identicals together, and it comes out of the radical sign as a single. Put 2 identicals together, and it comes out of the radical sign as a single, and you have to multiply those together, and you get 6. Well, we got the same answers we got here. That's good. Multiplication property of radicals says, you know, I can bust it down like this. I can take the square root of 4 and multiply by the square root of 9. What's the square root of 4? Yeah, that's 2. What's the square root of 9? Yep, that's 3. Do I get the same answer? I sure do. So there's lots of ways of looking at this same problem. The reason I'm showing you this and I'm showing you this is what happens when we replace it with variables. You have to understand this multiplication property. I think this will be a great way to do it right here. Okay? Okay. Use radical notation to simplify the following, to rewrite the following, simplify if possible. Okay, 81x to the 4th, that whole thing is being raised to the 1/4 power. That means this whole base goes under the radical sign. That's going to become your radicand. What's your index? Now your index is the 4. Okay? So what I'm going to do now, I'm going to do it the long way. That's 9 times 9. That's 3 times 3, prime factorization. I'm going to rewrite this. My index is 4. Here is my prime factorization of the coefficient. And then my variable, I'm going to write it in expanded form. With me so far? Okay, now that I've got it in exponent or in a prime factorization form and expanded form on my variable, let's do this. This index says if you can group 4 of the same together, it comes out as a single. Okay, I grouped 3 there. It comes out of the radical, so I've grouped 4 of the 3's together. So 1 3 is the root. 3 is the root of that. If I group 4 x's together, then x is the root of that. There's nothing left under the radical sign, so our answer is 3x. Did you follow me on that? Okay. You can bust it up if you want to using that multiplication property. We could say that's the 4th root of 81, which you can put in your calculator and get 3. And the 4th root of x to the 4th, these are inverse operations, and one undoes the other, and you get 3x. But when I taught it that way, no one understood it. So I teach it different now. I teach it 2 ways, I guess. All right, use radical notation to write the following, simplify if possible. We're going to go to a radical form. That's what radical notation means. So, this exponent of 1/5 applies to everything inside the parentheses. What is our index? Our index is a 5. So 32 x to the 10th goes inside the radical sign. This right here is our radicand. All right, so now I'm going to do it the long way. Slow and steady wins the race. 32 in prime factored form. Well, I know that's 4 times 8, and 4 is 2 times 2, and 8 is 2 times 4, and 4 is 2 times 2. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 2's that are being multiplied together. Okay, x to the 10th. This takes a little bit of time, but, you know, slow and steady wins the race. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. The index says group 5 identical numbers or variables together. It comes out of the radical sign as a single. All right. 1, 2, 3, 4, 5. Let's group those 5 together. That comes out of the radical sign. 1, 2, 3, 4, 5. That comes out of the radical sign. There is nothing left under the radical sign anymore, except for 1, and the 5th root of 1 is 1. So we take our answer, multiply it back together, and I have 2x squared. Okay? Not too bad. All right, here I'm using that multiplication property. I'm saying, well, that's the 5th root of 32 times the 5th root of x to the 10th. I used to teach it this way. 32 is the same as 2 to the 5th power, and taking the 5th root of something to the 5th power undoes each other, so it leaves you just 2. I think this right here is what used to confuse people. That's really confusing. Taking something and raising it to the 5th power is inverse operations with taking the 5th root. So what you're left with is 2x squared. Okay? That's kind of confusing. Anybody see the shortcut to get from here to here? All right. Don't use shortcuts if that's confusing. Stick with slow and steady. All right, what about this one? I'm going to use slow and steady. What's my index? Yeah, 1 over 3, my index is 3. 16, I'm going to go ahead and change that to well, no, let's go ahead and write it like this so you can see that everything, this whole thing right here is my radicand. Now let's do slow and steady. 16, that's 4 times 4. 2 times 2, 2 times 2, 2 times 2 times 2 times 2 times, here comes the 7 x's being multiplied together. 1, 2, 3, 4, 5, 6, 7. Okay, this one's a little bit different than what we've done up to this point. This says, the index says group 3 identicals together. It will come outside the radical sign. Okay, so these are gone. There's only 2 left here. 1, 2, 3. There's 3 x's there. They come out of the radical sign as a single x. 1, 2, 3. These come out of the radical sign as a single x. The 2 and the x must stay under the radical sign. So it's the third root of 2x. Let's simplify putting x times x together. Our final answer is 2x squared, the cube root of 2x. Ooh, that's a little bit different than what we've done up to this point, isn't it? Yep, that is simplified form. Make sure to get that one in your notes. I'm not even going to talk about all of this because it will only confuse you if you want to stop the video and look at it. But I really don't want to confuse you. I want to stick with slow and steady. Okay, remember power of a power? If I have x squared being raised to the third power, that means take your base of x squared and multiply it by itself 3 times. And each x squared is an x times x. X times x, another x times x, another x times x. Put them all back together and you get x to the 6th. Remember, if you have a power raised to a power, you multiply your powers. Power to a power, multiply your powers. Sounded stupid? Hope it sticks in your brain. Okay? Here I've got x raised to the 2 plus 2 plus 2 power. I don't even know why I put that in there. Oh, I know why I put that in there. We do have a rule that says if you're multiplying 2 exponents together and the bases are the same, you add your exponents. So really I kind of deviated here. I kind of went off in a different direction. That's one of our exponent rules. If you're multiplying numbers together and the bases are the same, you add your exponents. So that just shows you that we still get x to the 6th power. Okay, just a little review on exponents. All right, let's review, let's apply the rule to this problem. All right. Remember that x to the m raised to the n, if I have a power raised to a power, I multiply my powers. Here I've got a power raised to a power. Guess what we're going to do? Yeah, we're going to multiply our powers. How do you get a power of 2 and multiply by 1/3? Yeah, you can put your 2 over 1, multiply your numerators together, multiply your denominators together, and this right here simplifies to this right here with a rational exponent. See what I'm doing here? So, x squared raised to the 1/3 power is x to the 2/3 power, and x, I'm going to change my exponent here, x to the 1/3 power squared gives us the same thing. I just swapped places on my exponents. Now remember, if I were to take this and put this in radical form. Do you remember in the fractional exponent which one was our index? Yeah, it was the denominator right here. That goes there. Guess what goes in as our radicand? It's going to be x squared. So that denominator is your index, and the 2 is the exponent on your radicand. Okay, so the point of all of that, the point of all of that is if we have a rational exponent that's written like this, those are both the same, you can deal with it in 2 different ways and still get the same answer. You can make that exponent apply to your base of x and then take the third root of it. Or you can take the third root of your x, which we did here, and then apply the exponent to the whole thing. Whichever way you approach it, you're going to get the same answer. Now we have an activity in small group that will show you one way is easier to deal with than another. And it's going to be your preferred method. Okay, so here is our full definition of rational exponents. If m and n are positive integers greater than 1, with m over n in lowest terms, meaning that it's been simplified, then a raised to the m over n power, and I don't like the way it's written there. I would write a raised to the m over n power equals, this is the first way you can write it. Remember, the index is always your denominator. You can say the nth root of a raised to the m power, because m is your exponent on your radicand. Or you can take the nth root first of a and then raise it to the m power. All right, so that is our full definition of rational exponents, changing irrational exponents to radical form. As long as the nth root of a is a real number, as long as you're not trying to take a square root or a fourth root of a negative number. Okay, let's apply it to this. 8 raised to the 2/3 power. You can say that's 8 to the 2nd power and take the third root of it, which gives you, let's simplify our radicand. That's 8. 8 squared is 64. We can do this. You know, with a number, you can just plug that into your calculator. But let me do this. That's 8 times 8, 2 times 4, 2 times 4, 2 times 2, 2 times 2. Taking it the slow and steady route, if I do prime factorization, there's 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, 6. Group 3 of them together and it comes out of the radical sign. If you put this straight into your calculator, and I want you to try it, you should get 4 as an answer. Give it a try. I want you to know how your calculator works. Now I'm going to use the other definition. I'm going to take the third root first and then raise it to the 2nd power. Here's the other way we can do it. Take the third root of 8 first, and then take that answer and apply the exponent of 2. Well, the third root of 8 is 2. Let me write it this way. I know that prime factorization form of 8 is 2 times 2 times 2. Group those together, and that comes out as a single 2. But now we're squaring it, and we get 4 as our answer. Either way, you get the same answer. All right? Okay, so let's use radical notation to rewrite 16 raised to the 3/4 power, simplify if possible. Okay, 4 is the index on our radical, 3 is our exponent. So we're going to rewrite it like this. We're going to take the slow and steady route. Prime factorization of 16 is 2 times 2 times 2 times 2. The index of 4 says group 4 identicals together. That will come out from underneath the radical sign as a single. So the 4th root of 16 is 2. And now 2 times 2 times 2 gives you 8. Our answer here is 8. Okay? This is the other way you can do it. You can take 16, raise it to the 3rd power first, and then take the 4th root. When you do that, you get the 4th root of this really big number. And I didn't even want to do prime factorization on it. I let the computer do it. It came up with this. So let's group 4 identicals together. 4 more identicals together, and another group of 4 of the same number, and you multiply those together, you get 8. This is the shorter way to do it. It keeps your number smaller. Whoops. Okay. Let's use radical notation to rewrite the following. Simplify if possible. The exponent here only applies to a base of 8 and not that negative sign. It's like multiplying by -1. So we're going to take 4/3 of 8. Our index is 3, so we're going to take the cube root of 8 and then raise it to the 4th power. The answer is going to be negative. Prime factorization of 8 is 2 times 2 times 2. Index says group 3 together, and it comes out as a single. So this right here totally gets rid of anything under the radical sign. Now we're going to raise it to the 4th power and make the answer negative. 2 times 2 times 2 times 2 is 16. Our answer is negative 16. If you do it the long way, it looks like this. Remember that? Yeah, we don't want to go that route. But we still do get the same answer. Okay. Use radical notation to rewrite negative 64 raised to the 2/3 power. Simplify if possible. This time we are including the negative because it's inside parentheses. So it's negative 64 is our radicand. We are going to take the cube root of that first and then square it. Now, if I do prime factorization of negative 64, that's negative 8 times a positive 8. Negative 8 is negative 2 times negative 2 times negative 2. The positive 8 is positive 2 times positive 2 times positive 2. So I wrote my prime factorization like this to make the signs work out. Now, group 3 identicals together, and they come out of the negative sign, or out of the radical sign. So those come out as the negative 2. These come out as the positive 2. There's nothing left under the radical sign. Negative 2 times positive 2 is negative 4. And negative 4 squared means negative 4 times negative 4, which is positive 16. Okay? Or you could have gone the long and ugly route. Yeah, I'm going to do my roots first and then raise them to the power. Okay, back in CPM3, if you had CPM3, we went over the definition of a negative exponent. If a is raised to the negative n power, that's the same as 1 over a to the positive n power. Remember that from CPM3? You are not simplified if you have a negative exponent. You are simplified if your exponent's positive. It's okay if it's in the denominator. Okay, so the definition of a raised to a negative rational exponent works the same way. If I have a raised to the negative m over n, that's the same as 1 over a to the positive m over n. Okay, we're going to have to remember that. Let's see how that's applied. Use radical notation to rewrite the following, simplify if possible. Okay, first of all, we have to get rid of a negative exponent. We do that by putting the whole thing under 1. Now, let's see if we can simplify this rational exponent, change it to radical notation form. My index is 3, so it's the cube root of 64 raised to the second power. I'm going to go to prime factorization form on my 64. I'm going to group identicals, 3 identicals together. It comes out as a single, so that group comes out as 2. That group's gone. Group that together, it comes out as a single 2. There is nothing left under the radical sign. So 2 times 2, we're going to multiply that and then square it. So that's 4 squared, that's 1 over 16. Okay, this time the exponent applies only to the 16, not the negative sign, because this negative 16 is not in parentheses. It's like multiplying by negative 1 right here. So let's deal with this 16 raised to the negative exponent. We make it a positive exponent by putting it under 1. And I just park the negative sign out front. So now let's take this rational exponent and change it to radical notation. My index on my radical is 4. We're going to take that answer raised to the 5th power. 16 is 2 times 2 times 2 times 2. I'm going to group 4 of the same number together and it'll come out as a single. So the radical is now gone. That's replaced with a 2. Now 2 to the 5th power is 32, so my answer is negative 1 over 32. Pause the video anytime you like. All right, use radical notation to rewrite the following. This time the negative is part of the base, and I'm raising it to a negative exponent. Let's make that exponent positive by putting the whole thing under 1. Now let's go to our radical notation. My index on my radical is 3, so the cube root of negative 27, that whole answer is going to be squared. Negative 27 is negative 3 times negative 3 times negative 3. I can completely get rid of that radical. Negative 3 comes out and the radical is gone. Last thing to do is to take negative 3 and square it. Negative 3 times negative 3 is positive 9. Okay, let's rewrite this one. I have a negative exponent. Let's deal with that first. To make it positive, I put the whole thing under 1. So let's put that under 1. Now let's deal with the radical, the rational exponent. The cube root of 8, that answer raised to the 4th power. 8 is 2 times 2 times 2. So the cube root of 8 is 2. And 2 raised to the 4th power is 16, so my answer is 1/16. All right, here's some vocabulary. To simplify, x to the 1/2 power times x to the 3/4 power, we add our exponents. We can add our exponents because our bases are the same. Let's use the properties of exponents to simplify a to the 2/3 times a to 5/3 with, write the results using only positive exponents. They don't want it in radical form. So just to remember, if your bases are the same, you add your exponents. Well, here my bases are the same. I'm going to add my exponents. Since my denominators are the same, I've got 2/3 plus 5/3. That gives me 7/3. And now let's see, it does say write write the answers with positive exponents. That's our answer. I prefer the fractions written that way, but we'll accept both. Whoops, I keep hitting the wrong thing. If they had asked us to write it in radical form, it would have been one of these, but they didn't, so let's move on. Okay, let's see here. Use properties of exponents to simplify the following. Okay, if I have a product raised to a power, then each one of these factors is raised to that power. So I have 32 to the 1/5 is going to be cubed times x to the 2/3 being cubed. You have power to a power, you multiply your powers. That's where this came from. 1/5 times 3 is 3/5, so 32 to the 3/5. And x to the 2/3 multiplied by 3 is x squared. Okay, 2/3 times 3 over 1 is 6 over 3, which is just 2. That's where they got that. Okay, now let's go ahead and deal with taking 32 and raising it to the 3/5 power. My index is 5, my exponent is 3. 32 in prime form is 2 times 2 times 2 times 2 times 2. Group 5 of them together, it comes out as a single 2. 2 to the 3rd power is 8, and we are done. There is nothing you can do with x squared. Look at B. I think I'm going to simplify the numerator first. Since the bases are the same, I can add the exponents. Since the fractions that I'm trying to add here don't have common denominators, I'm going to create common denominators, and now I can subtract. Now if you remember back to CPM3, if we're dividing, which is what we're doing here, and our bases are the same, what do you do with your exponents? Yeah, you take the top exponent and subtract the bottom exponent. So we'll do that. But I can't subtract until I have common denominators. My common denominator is 12. So negative 3/12 minus 8/12, that's negative 11/12. We are not simplified until we have positive exponents. How do you create a positive exponent? Put the whole thing under 1. There's our answer. Okay, use rational exponents to write as a single radical. All right, the cube root of 5 is 5 to the 1/3 power, and the square root of 2 is 2 to the 1/2 power. I'm going to create common denominators here. This is kind of tricky. So between the 3 and the 2, your common denominator is 6. Common denominator of 6 means this is going to be a 6th root and this is going to be a 6th root. Well, why don't we pull that common denominator of 6 out like this, which means we're going to take the 6th root of this whole thing and then simplify your radicand. Yeah. Yeah, isn't that fun? We might need to practice that one some more. All right, use rational exponents to simplify this one. Assume that variables represent positive numbers. Okay, they want us to take this and create a rational exponent. Well, how about if we use that multiplication property first? The 4th root of 16 is 2. And if you're going to use rational exponents, your denominator is 4, your numerator is 2. See what I did there? 2x we always reduce our fractions. X to the 1/2 power is the same as the square root of x. So our final answer is 2, the square root of x. Whew. You know, this whole business here of taking the 4th root of x to the 2nd power and changing it to x to the 2/4, which is 1/2, which gives you the square root of x, that's tricky. That's very tricky. Okay, looks like we're pretty much to the end. Here's just kind of a recap of a few of the things that we've learned. Okay. And we're just going to assume anytime that we take the square root of any variable that the answer is going to be positive. All right, for your homework, this does come up. Let's go back over irrational numbers. This was in the first lesson. Irrational numbers are numbers that never terminate and never repeat. You get an irrational number when you take the square root of a non-perfect square, or the cube root of a non-perfect cube. Here's an example. The square root of 5 gives you a decimal that never terminates and never repeats. Now, if your homework asks for an exact answer, that's what they're looking for. If they want you to approximate, and they will say the word approximate your answer, and they will tell you how to round, then you're actually going to take the square root of whatever your number is and enter that as your answer. You might need to watch one of those videos and review the rounding rules. How do you round to the tenths place? How do you round to the hundredths place? How do you round to the thousandths place? Okay, and one more thing. Here's your TI-30, pointing out a few buttons. This button right here is your power button. Okay, so if you took 2 and hit that power button, whoops, like that, whoops, like that, and 3, what that's doing is 2 to the 3rd power. When you hit enter, you will get 8 as your answer. So that's how you use your power button. This right here, right above your x squared, is your square root, and it might be in yellow. I don't know why it's in green on this one. I've never seen it in green, but whatever color that it is, you access it by hitting the second button. So if the square root is in pink, your second button will be in pink. So how do you enter? And then your nth root is this one right here above your power button. To actually enter and get the cube root of 64, here's your keystrokes. See this little X here? You have to put that in first. Your index, my index is 3, so I'm going to hit 3 first. Then I want my radical sign, so second, hit the second button. Hit this button here, my power button, because that little sign is above it. Put your 64 in and hit enter. You should get 4 as an answer. Practice with that. You need to know it for the test. That's all I have for you. That's enough, isn't it? Okay, good luck with this.